Okay. Hello, can you hear me? Hello.
Yes, hello.
Okay, how are you?
I'm fine. And you?
Alhamdulillah, I'm fine. Thank you.
Good.
So I hope you also practice our before first day and second day classes. So
Okay.
today is our third day, and we will start. Okay.
Okay.
So I share my screen. Okay. So I also recorded this session so that you also get to the recorded video classes for your practice. Okay.
Okay.
Okay, so I just share my screen. Wait a minute. So can you see my screen now?
Yes.
Okay, so we'll start. So hi and welcome to the 7 days online training session on Google Earth Engine for remote sensing analysis. I am course coordinator. So basically this course will be taken total 7 days, and we already covered the 2 days, and this is the full course module of the total 7 days. Okay, we completed all of the course content within the 7 days. Okay, so you can also practice with me for the learn better, and all time I will send you all of the practice code, and you can also get the video recorded session, so you can just practice, and then face any problem just let me know. Okay, so basically today is our third day, and the third day course content will be that today I also try to discuss about that how you can easily filtering and displaying the satellite images. Mainly in this time I also try to discuss about the Sentinel-2 satellite imagery. Okay, and after this how you can easily make the normalized difference water index from the Sentinel-2 satellite imagery. Okay, so in this time I also try to discuss about that how we can easily filter the Sentinel imagery, and previous class I also try to discuss about the Landsat imagery, how we can easily filter the Landsat. Okay, so I hope you can practice about the Landsat imagery, how we can easily filter the Landsat imagery. Okay, so I hope you can practice this part, yeah, for the filtering the Landsat imagery.
Yes, filtering. No.
Oh,
Landsat.
yeah, filtering the Landsat satellite imagery we already covered the second classes.
Yes.
Yeah, so in this time we also try to learn
Yes.
about that Sentinel-2 imagery. Okay, so that and
Okay.
also make the NDWI map, and then we move to the NDVI time series chart. Okay, so what's the condition of the NDVI? We also try to make the chart for the NDVI time series chart, and we also try to show you that how you can easily export any shape file from the Google Earth Engine platform, and then how to calculate it any indices from the satellite images, and then how to add the gradient legend. Okay, and then also
Okay.
move to the land surface temperature monitoring part for using the MODIS as well as also Landsat imagery, then also calculated the NDWI calculator for the MODIS and Landsat data. So we will start step by step, then we will try to cover this part. Okay, so first of the filtering and visualizing the satellite images in Google Earth Engine platform, we already covered the part for the Landsat imagery, and in this time I also try to show you that how you can easily filter the Sentinel-2 satellite imagery. Okay, and when you want to filter any satellite imagery, we need to use at the 3 factor. First factor is that the region of interest. Suppose I need the Landsat or Sentinel any image. When you want to filter, first factor is the region. Okay, then second factor is that image properties or image metadata. Okay, and third factor is that is image specific time period. Okay, suppose you can see I need a Sentinel-2 satellite imagery for the Dhaka city, and I also need the some specific image properties I need only for those images which image will be not more than 1% cloud cover. Okay, and I also need the image any specific time period. It can be a year, or it can be any rainy season or dry season or wet season, any period of image. Okay, so this is the filter time. Okay, so this is the main three factor. First factor is that region, second factor is the image properties, third factor is that image time period. Okay, so we, according to this factor, we try to filter the image, and then we can make the NDWI map any specific period. Okay, so I will show you the practically in this time. For this I simply open my code editor in here. So I simply open the code editor. So in this time, suppose I want to calculate the NDWI for any specific region. Suppose I want to work with the region for, okay, so I simply import the region. Wait a minute. So first of all, you need to import your shapefile, and we already covered that how we can easily import our shapefile. Okay, so in this time I simply use a my shapefile. You can see I use a shapefile. Suppose this shapefile is that I want to use here the lot of shapefile. I want to use here the BD district shapefile. In the BD district shapefile, we can easily access that 64 district of Bangladesh. Okay, I want to use this shapefile, and I already import this shapefile in here. Okay, and in this time I simply import. Okay, simply import. You can see this shapefile will be imported, and this shapefile has the total 64 district. Okay, from the total 64 district I want to select only for the one specific district. Okay, then work with this. So in this time I simply use a, suppose I can simply take a variable and give the variable name is the suppose RY. Okay, then I filtered this table. Okay, because this table has a total 64 district, I want to filter this table. I simply call the table, because this table variable stored total 64 district. Okay, so I simply use the table, then I use here the filter. Then how I can filter? I add engine filter dot equal, then what's equal what, I simply put here the, you can see in this time I go to my attribute table. So here you can find the attribute table under the feature tab. So here you can see this is the attribute table for the name 2. Under this name 2, you can put all of, you can get all of the district name in Bangladesh. Okay, so in this time I simply use the name 2, and then I simply use here the name 2, and my region district is the user the select. So this is my district name. Okay, so you can see this is the district. I want to show the district because in this time, the recent time, Sylhet has a lot of flooded area already. So we also observe the what's the condition in this time in Sylhet for increasing the flood area. Okay, or flooded area. We can observe the what's the condition of the Sylhet in the flooded area. How many water level will be increased during the flood. Okay, during the flood time. Okay, so I simply copy the ROI, and then this variable I just copied from here, and then simply paste here. I want to show the, I also use there the map center object function for focusing this shapefile, and Zool will 10, and then click to the run. So now you can see we will get our shapefile. Okay, you can see this is the district of Sylhet, and now we want to observe what's the condition of the flood and how many water will be increased for the during to the flood, and everything we can do. Okay, so first of all, in this time here we use the Sentinel-2 satellite imagery. Okay, for observing the flooded condition. So for this you need to import here the Sentinel-2 satellite imagery. Okay, so for this I simply go to the browse data catalog. So in this time I simply use here, suppose I simply go to the Sentinel. Okay, I go to the Sentinel imagery, and then I simply filter with my specific time period for the Sentinel-2 image satellite. Then we can make the NDWI map. It's identify the water surface, water in the surface of satellite. We can easily identify. You can see. So here I simply okay, so here I can get all of the collection about the district. You can see. So in this time I can get all of the Landsat image. You can see Sentinel imagery. I want to use here the Sentinel-2 multispectral instrument. Okay, so I simply use this imagery, and then here I can get the surface reflectance. Also I can get here the top of atmospheric. Okay, so now you can see here, I use here the top of atmospheric data set. Okay, so here I can get the satellite image of the Sentinel-2 multispectral instrument. Okay, so I can simply use the satellite imagery and make the filter the satellite imagery according to the region of select. Okay, so in this time I simply use this satellite imagery. You can see this is the collection snippet of the Sentinel-2 satellite imagery. I simply copy the collection snippet and just paste in my code editor. So I simply paste in my code editor. Okay, then I simply put a variable name. I simply put the variable name is that, suppose this variable name is that, I simply put the variable name, suppose Sentinel-2. Okay, so now you can see this is my Sentinel imagery. It is stored in a variable. Okay, this variable name is that Sentinel-2. Okay, so in this time you can see this is my collection. So in this time you can see this is my collection, and this collection is stored in a variable Sentinel-2. Okay, so now I want to filter this collection. Okay, so for this, suppose I want to filter the image in the 2 season. Okay, suppose dry season or rainy season, as well as also rainy season, I want to filter these images. Okay, so for this I simply take a variable, suppose this variable name, I simply put the variable name is that, suppose image dry. I filtered the 2 period image. Okay, a dry season and wet season. Okay, I filtered these images. So I simply use the image dry, then I simply use the Sentinel-2 and then simply paste here. After this I simply use a function, this function called the filter bounds. Okay, we already know about the filter bounds. Filter bounds is intersecting with your ROI or with your shapefile. In this time shapefile name is the ROI. Okay, and then we also need to add here the dry season date. Okay, so this is the dry season date. I simply put here the dry season date is that, I can simply put here the filter date function, and I simply use here the filter date. Okay, and give the dry season date. I simply use here the year of 2022. So I simply put here the year of 2022. Then I simply put here the 1st January from. Okay, so I need to use here the quotation. Then use here the year of 2022, 1st January. Okay, then also put here the end date will be, I define the image dry season with the April. Okay, so I simply use here the 2022 suppose April. Okay, and then I simply put here the 30. Okay, so this is my one time period. Okay, so I define this is the dry season time period. Okay, then I simply use here the another things is that it's called the short function. If you want, you can use here the filter metadata function in here. Suppose you can simply use here the filter metadata. Okay, then you can simply put here the image properties name. You can see this image properties, different types of image properties, cloud pixel percentage, cloud coverage assessment. Okay, so which unit, I simply put the cloud pixel percentage and then I simply paste here. Okay, this name, then I simply need the cloud pixel percentage less than, suppose less than 1. Okay, so this in this time when I run this code, I can get only for those images which image will be not more than 1% cloud cover using the filter metadata function. Okay, so in this time I use here the another function instead of the filter metadata. I simply use here this function is the short function. Okay, so this is the another function for filtering the image properties. Okay, so I simply use that short the image properties, you can see. Then I also use here the false function. It means that in this time this image will be shorting as according to the cloud pixel percentage and get the less cloud pixel percentage. Okay, so in this time then I simply use check how many images will be available here. I want to check it, so I simply check it. Okay, so I simply check it how many images will be available between this time period. Simply print and copy the image dry season, then I simply paste here. Then I simply use here the this function is I simply use here the size function. Okay, then click to the run. We can get here the total 94 images. Okay, between this time period. Okay, I want to use the total 94 images. Okay, and I use it in this time I use here the mosaic function, so that I want it will be composite all of the images in a one collection. So I simply use here the mosaic function, and then I simply it will be clip with my area. My area is that ROI. I simply put here the ROI. Okay, then I simply run this. I simply add the map.addLayer function in here. I want to show the result. I simply use the map.addLayer, and then I simply copy the image dry season and paste here, then click to the run. So you can totally get a black and white color image, you can see, because I did not add any visualization in this time. So I simply use here the visualization. I want to use here the before B5, sorry, before B3 and B2. Okay, and also increase the state 98%. Then use here the apply. So now you can see I can get these images. Okay, for the time period between this time period. Okay, so I simply import this, and then I simply copy the visualization variable name and paste here. Okay, I simply put this is the dry image. Okay, and another image I also take here the another image. So I simply copy and then simply paste here. I simply use here the wet season. Okay, wet season. Okay, wet season. I simply use here the wet, and then in this time I just put here the recent date. Suppose May. I want to use here the I use here the so I use here the April, 1st April to May. What is the date condition? You can see we can access the date May 19. Okay, 19 May. So I simply use here the May 19. Okay, and I want to check the images in here. So I simply use here the map dot add layer, and then I simply copy the image wait season. Okay, then also copy the visualization variable name and paste here. After this I also use here the dry image. In this time it will be wet image. Okay, so I simply use here the this is the wet image, and then click to the run. So we can get the two images, you can see. And we can easily make the land cover classification using these images. So when you want to work with the Landsat images, then we can easily work with this. Okay, in this time here you can see, when I work with the wet season and recent time, we can find out the lot of flooded area in this district. Okay, in the Sylhet district, in this time we find out the lot of flooded area. When you calculated the NDWI, we can easily identify the lot of water pixel value in the surface of the Sylhet recent time, because in this time it will be occurred the flood. Okay, still it will be happening. Okay, so you can see here we filtered the two season. First you can see dry season, there is the no cloud or very less. Also I can see this is the wet season image. Here we can get the some cloud. Okay, for the rainfall they are created the lot of cloud. In this time you can see this is the cloud pixel, also cloud pixel, also cloud pixel. Okay, lot of cloud pixel will be available here. Okay, in this time we can easily remove all of the cloud from here, from the satellite imagery, and we can easily get the clear condition of the satellite imagery. Okay, but in this time I will not showing this part. I will try to show you the next class how you can easily remove the cloud and other things. Okay, so in this time you can see I can get the two period images, wet season and dry season, and in this time I want to make the NDWI, so that I want to access the water in the surface of this region. Okay, I want to access the water. Okay, so for this, when you want to access the water, we need to use a formula. This formula is that NDWI formula, and NDWI formula is that, you can see NDWI formula is that green band minus near infrared band divided by green band plus near infrared band. When I just use the equation, I can easily calculate the NDWI, and NDWI is the normalized difference water index. We can easily calculate the water index on the surface. Okay, so in this time here you can see, in this time this image for the image dry season and also image wet season, we can get total 17 bands. Okay, you want to check the bands about the image, you can see. So here you can see total 16 band. Okay, total 16 band we can get. Okay, in this time from this 16 band I want to need only for the two band, green and near infrared band. Okay, I need only for the green and near infrared band. Okay, so that's why you can check what is the green and near infrared band from the bands of the satellite Sentinel-2 imagery. You can see green band, you can see this is the green band B3. Okay, green band is the B3. And what is the near infrared band? You can see near infrared band is the B8. Okay, this is the B8 for the near infrared band. Okay, so in this time I need to select this two band and store in a variable. So I simply take a variable and give the variable name is that, you can use the any variable name. Okay, so in this time we can use here the another thing is that I want to calculate the NDWI for the dry season. So I simply take the variable name NDWI for dry. Okay, then I'm simply call the dry image. Okay, you can see this is the dry period image. It is stored in a variable image dry. I simply copy the variable name and then simply paste here. Okay, then I simply use a function, this function called the normalized difference. What is the normalized difference? You can see what is the normalized difference function. When I use this function, you can, it automatically calculated, you can see first band minus second divided by first plus second. So in this time you can assume that this is your band, one band, suppose this is the green band, subtract with near infrared band divided by green band addition with near infrared band. So when I use this function normalized difference, then it automatically calculated this equation. Okay, it automatically calculated. So in this time I just need to select here the band name. So I simply select my two band in name in here. First band is the B3 and second band is the B8. Okay, so in this time I calculated the NDWI dry season. For the dry image, you can see this is the dry image. I use here the normalized difference and then I calculated the NDWI for the dry season. And then I also use for the wet season. I simply copy the variable name, copy the code, and then I simply paste here. I just simply change here. This is the NDWI for wet season, and I also need to add here the wet image. So I simply copy the wet image variable name and paste here, and it is the same. Okay, so you can see now I want to add here the map, NDWI map. I simply use here the map dot add layer, and then I simply call the NDWI dry. I want to show the NDWI for the dry season, and then I simply put here the color mean. I want to show the mean pixel value. It will be start from the -1 up to max NDWI pixel value up to 1. I also want to add here the plated function. Plated. So in this time you can see for the NDWI positive value or closer to the positive, it's identify positive pixel value or closer to the positive pixel value, it's identify the surface water. Okay, it's identify the surface water, or negative pixel value or closer to the negative, it's showing, it's identify there is the no water. It can be vegetation or it can be water, it can be built up area or it can be barren land, but there is the no water. Okay, but when you get the positive pixel value, it identify it must be water. Okay, so in this time I simply use here the, suppose I want to show which pixel value is negative. I want to show the result as a green color. Okay, which pixel value is greater than -1 but plus than +1. I want to show the value as a, suppose I want to show here the value is that, suppose I use here the value is that blue. Okay, so in this time when I click to the run, we can see what is the condition of NDWI for the dry season. We can check it. And this is same way for the another things for the wet season NDWI. Okay, so we also need to add the another color. Suppose I want to show the another color is that for the white. Okay, okay, so in this time we also add here the for the another things for the NDWI for the wet season map. So I simply copy the wet season NDWI and paste here. Okay, I put the layer name. This is the layer for wet, so this is the dry NDWI. And this is the wet NDWI. Then click to the run. So you can see what is the difference between the wet and dry. So this is a dry NDWI. And this is our wet NDWI. Okay, so in this time this color plated is not matching, so I use here the another color. Suppose I use here the blue color, blue, and use here the white color for the better looking. Okay, and then click to the run. Okay, so this is a lot of pixel with the green color, so it will be not work. So in this time, wait a minute, so we can use the different types of color combination. So in this time I use here the better combination. What is the better? We can use the better combination. So green, I can simply use here the red. Okay, then I use here the, suppose this is the white and this is the blue. Okay, then click to the run. So in this time here you can see this red pixel value identify there is the no water, but this white and also you can see blue pixel value identify there is the water. Okay, so you can see this is the wet season, you can see this is the dry season, this in this time this is the dry season NDWI, and this is the wet season. You can see this is the wet season NDWI. There are the lot of white pixel value, also you can see some blue pixel value, so it's identified there are the lot of water pixel in the in this present time. Okay, you can see, and this is the dry season. You can see this is the wet season, dry season, wet season. Okay, you can see, and when I want to click on this map, you can see the result of pixel value for the, I simply click the inspector tab and press on this pixel value. You can see we can get here the value is that you can see positive. Okay, it means that this is the water pixel. Okay, so in this time for the NDWI we can easily identify the water. You can see some water, lot of water in this time in here. We can easily export this map, and we also try to import this map in ArcMap software and add here the different types of legend or other. We can easily do it. Okay, so if you have any question you can ask me in this time. Any question or any doubt you can ask me.
You can return how you saw the chart.
Time series chart.
Yes.
Okay, so we also covered this next time, no problem. So we also try to cover this no time. So in this time, regarding this code, do you have any question you can ask me?
Just now I see the chart on the inspector panel.
Yeah. Any question about this code? We can easily make the you can easily make the time series chart. We covered this part.
Okay.
For the next slide, no problem.
Okay.
So here you can see, and this color is not meaning anything because we can use the any color in here. And when you download this image as a TIFF format, then we can easily open the ArcMap software and work with this. Okay.
Okay. And with the top of atmospheric image and the reflectance image, what is the better for the land cover classification?
So when you talk about the land cover classification, then we also try to discuss about this. So which satellite image is the better for, what's the band value is better for making the land cover classification map. Okay, so we will start the land cover classification from the fifth classes, fifth or fourth classes, or actually next class. We also try to discuss the 2 or 3 class for only for the land cover classification. We learn all of the details in land cover classification map, no problem. Okay. So in this time, this is the NDWI map. Okay, so we can easily make the NDWI map, and we can see the 2 period image. You can see in this time, this green pixel value, you can see this is the dry NDWI and this is the wet NDWI. You can see what is the difference between the 2 images of NDWI. Okay, we can easily export this map, and we can easily make the map layout or other details in the ArcMap software easily. Okay, so in this time I will go to my next slide. So in this time I will try to discuss about that. Suppose in this time I will try to discuss about that how you can easily computation using satellite images. Okay, so in this time I will try to show you that how you can calculate any indices using the any satellite imagery, how you can easily calculate the different types of equation, suppose NDVI equation, NDWI equation. So NDWI we already covered this part using the normalized difference function, but all of the we can use the different method for calculating the indices using the Google Earth Engine platform. I also try to show you all of the method so that you can easily understand this part. So in this time I simply open my code editor. Okay, so I simply open a new code editor. So in this time here I use a new code editor. So from the code editor I simply suppose I want to work with the Landsat image. Okay, I want to calculate the Landsat using the Landsat image. I want to calculate the NDVI or the normalized difference vegetation index. What is the condition of the vegetation any particular region? I want to check it using the Landsat imagery. Okay, so first of all you need to import the Landsat image collection in here. So in this time I simply suppose I want to work with the top of atmospheric dataset for Landsat 8. You can see this is my image collection. I want to use this image collection for monitoring the NDVI. Okay, so I simply copy this convention snippet and just paste in my code editor, and then I simply put a variable name in here. So I simply put the variable name is that, suppose this variable name is the suppose L8. I put the variable name. Okay, so in this time here you can see this whole collection of the Landsat 8, it is stored in a variable. Can you guess it? What is the variable name? Can you guess it? What is the variable name in here?
Li.
Yeah, L8.
L8.
Yeah. So this variable name is the L8. So in this time it stored the variable L8. So now I want to just filter this image, and then I can easily calculate the NDVI. Okay, so I want to filter this image. Okay, so for this I want to filter this image, and we already know about the filter, how we can easily filter this image collection. Okay, so we can easily filter it, and then